this third session on electricity provision to households in displacement settings. I'm Jonathan Arkemi, working with the GPA, which is the Global Platform for Action, which ultimate objective is to promote and push to bring SDG 7 to the displaced population and their host community, and as well supporting the effort of the humanitarian organization toward energy transition. The workshop is part of our activities to support knowledge sharing and built on lessons learned and good practice that derived from implementing project. And this is what has been done through the two last session and this session. We provide the audience with stories from the field of project that has been implemented. And then there is a discussion, Q&A session where the audience can ask a specific question to the speakers related to the project that has been presented. Today, I'm thrilled to be joined by Maher Maimoun from UNHCR from Jordan. He will present you the project they are currently designing and working on, which is to provide a dispenser, which is basically monitoring and control system on the demand side of the distribution of electricity. So after the session, you can please ask also all the questions during the presentation in the chat. Also, please introduce yourself in the chat just by writing your mails and your name and your organization, and then we will come back to the question you put in the chat during the Q&A session. Thank you very much for joining, and Maher, the floor is yours. Thank you.
Maher, you are muted.
Yeah, Maher, I think you are muted, and if you can just share your presentation.
Oh, got it. Can you hear me now?
Voilà. Yeah.
Perfect. Thank you so much. Perfect. On behalf of UNHCR Jordan, I would like to thank you, Jonathan, for your kind invitation to be speaking today about our experience in the past few years regarding energy solutions, as well as the proposed solutions right now we're designing in order to resolve other challenges related to energy and environment. So I'm thrilled to be here to be speaking about our experience, and we always believe in knowledge share to benefit other NGOs and humanitarian organizations from our expertise as well. So basically, the topic of today's presentation is the energy dispensers combined with the solar project that we used in our camps. In Jordan, we have two main refugee camps, AZRA Camp and AZRA Camp. So to start with that one, and before that, I would like to also to mention that the United Nations has an environment program. It's called UNEP. It's focusing on greening the blue and how our initiative solutions can support the UN system, starting from UNHCR in addition to other UN organizations, to focus on environmental and sustainability solutions, not only, let's say, electricity or energy. So holistic, successful solutions are always focusing on sustainability. To start a few steps in the past, what was done in UNHCR Jordan, we got a donation from KfW to build a huge solar farm in AZRA Camp. The capacity or size of this solar farm was 12.9 megawatt. Gladly and always proud to say that several tens and hundreds of refugees participated in building this solar plant. This is what we always focus on in sustainability, to integrate even the refugees in such creative and implementations of solutions. This solar farm was supposed to cover 100% of the electric basic needs of the shelters based in AZRA Camp. The environmental impact of this solution was really big. It's reducing about 15,000 tons of CO2 per year, which is significantly a huge amount of carbon emissions reduction in such a refugee camp. So talking about the second camp, which is the AZRA Camp. This camp also got a donation by IKEA Foundation on 3 phases. The total or the sum of the solar farms built at AZRA is 5.0. It was designed and installed and operated since more than a couple of years, and it's covering almost about 60 to 70% of the shelter's needs at AZRA Camp. Also, the refugees participated in capacity building. They got trained how to build and operate and maintain these solar projects, in addition to environmental impact of having more than 6,000 tons of CO2 reduced in that camp. So we're talking here about 3 pillars. It's energy saving or bill saving, in addition to involving the refugees in finding a solution which has a social impact, in addition to environmental impact in these villages. So these solar plants were built and calculated to cover, we said in AZRA, to cover 100% of the needs in AZRA and almost 70% for AZRA Camp. To do what? It was supposed to give the basic electric needs for the shelters and refugees, like lighting units, TV, charging the mobile phones, fans, and washing machines, in addition to mini fridge to preserve the food in these shelters. So these were calculated to be around 2.6 kilowatt hours per day per shelter. However, during the COVID case and during these times, the electricity needs jumped as a normal growth of having e-learning and other growth factors that impacted the consumption. So when we talk about in general about a growth might be about 10 to 15% annually due to having more kids, more shelters, more appliances inside the shelters. However, during COVID, we faced challenges of having an increase more than 35% due to several reasons. We mentioned the e-learning, and by default efficiency of energy systems and appliances goes down, so the consumption goes up. In addition to other people, because of its free electricity, they're using electric heaters in winter and they're using air conditioning units in summer. So these factors increased the bills significantly, and definitely this affects the budget, and in return it affects the POC budget of other educational and safety and other pillars. So here comes the solution of our today's topic, which is called energy dispensers. Energy dispensers is a smart metering device. As you can see it here in this screen, it's a small one like a breaker. With the screen, it's connected to the internet. We put a limit for each shelter, and any shelter, let's say we put a daily limit of 2.6, and any shelter that exceeds this amount, they will have a power cut off. And we're planning to have infrastructure to have a SIM card and charge it through a prepaid service. However, this is having challenges to be implemented in Jordan as a prepaid service because we're not legally authorized to sell electricity. So this has what we call a medium-term discussions with the electric utilities and how this can be integrated. However, to describe the energy dispensers project, as you see, it comes with different models. However, with the same concept that records the energy pattern and the energy consumption of each shelter, and it shows up an alarm, sorry, an alarm and control which shelters are exceeding the consumption designed for them, and we can put a cap when the electricity will be cut off in order to raise awareness of responsible consumption and energy management in camps, because this is definitely part of sustainability. We cannot say the sustainability goes only to solar energy. We have what we call energy pyramid that starts with responsible consumption, energy management, then we go up to energy efficiency, and the final thing goes to solar project. So we cannot keep building solar farms, and we're facing such a significant growth in the consumption. So here comes the what we call the lesson learned from our experience in Jordan, that energy consumption need to be controlled. We focus on energy efficiency like LED lighting and thermal insulation of shelters, and the final thing, we go to solar project which pumps clean energy to meet these needs. So what is the cost and the outcomes? This outcome, I will give you an example. Sometimes when you have a significant growth in the consumption, unfortunately, sometimes the camp management will go to reduce the hours, and this goes as a negative impact to all refugees. So one of the basic outcomes of the energy dispensers is to have a fair, equal energy allocation for all refugees. We cannot say just for this village they're over-consuming, and as a consequence, circumstance of this extra consumption, that village, whole villages or the whole camp will be impacted or affected. So we're looking for a fair energy allocation for all the shelters. Second thing, we want to have a higher electrification hours. We have a vision to provide a 24/7 electric grid or electric energy to the shelters in order to manage their credit the way they want. We cannot force, let's say, for 6 hours or 9 hours. We give, let's say, 2.6 kilowatt hours or 3 kilowatt hours per day, and they can manage it the way they want. This gives them freedom of using the energy in a responsible way and the way they find appropriate. Outcome number 3 is one of the main focuses as well, which is we're looking to reduce the carbon footprint of camps. Because as you know, in any country that has refugees and refugee camps, these host countries might have already challenges in water, energy supplies, and other, let's say, job opportunities. So we're looking here at UNHCR in having UNHCR refugee camps as green camps with positive impact on the host countries. One of them is reducing the carbon footprint, creating jobs even for the local people living there, and impacting social life in these villages. So this is 3 main outcomes of energy dispensers that we're looking to implement soon in Jordan. Talking about the budget needed for implementing these solutions for all shelters in both camps, ZATRI and AZRA Camp, is between 4 to 5 million US dollars. Now we're looking forward to secure funds to implement this interesting and needed project. Duration will be about to implement this solution in all shelters. It might range based on the installation criteria in these camps, but ranging between 1 up to maximum 3 years from now, from A to Z in the timeline. Now, going to measurable results in addition to environmental impact, this will significantly give a positive impact on the POCs residing in ZATRI and AZRA camps. The people or refugees living in these camps are estimated to be 120,000 refugees. So such a project will impact the daily life of these refugees in getting more hours, better learning, better health systems, and better entertainment as well. Now, for the capacity building, definitely implementing huge amount of energy dispensers, will include capacity building, same way we did it for the solar project. We will include local refugees from the camps in the installation and in the operation and maintenance, due to the what we call, even after installation, these will need programming, sometimes configuration, and other simple maintenance things. And these jobs and tasks can be done by these refugees under professional training and under supervision of our technical team as well. Cost saving, which is something really important in addition to social and environmental impact. This project is estimated to have a savings of 1 to 1.5 million US dollars per year. This takes us to about a payback between 2 to 3 years. And this is considered to other energy projects something really economically attractive to be implemented in those camps. So we mentioned here direct benefits, financial benefits, in addition to other direct benefits regarding the environment and the refugees and the social life in these refugees. We also appreciate all partnerships and the donors who are working with us on the energy challenges, like EKI Foundation, KfW, Ministry of Energy, and other donors, and the regulational companies and electric utilities working or supplying electricity to both camps, AZRA and AZRA Camp. So this was basically the existing case, in addition to a brief historical information and challenges, and how we were trying to resolve the challenges, lessons learned, and what is the next steps regarding the energy management and how to reach a 24/7 powered refugee camps with solar power in order to maintain a healthy lifestyle and good livelihood, in addition to an eco-friendly operation of these camps. This was a brief summary, and I will leave the floor to Jonathan, maybe to open the questions or the discussion panel, and I'm glad to answer any question related to that. So thank you so much.
Thank you so much. Thank you very much, Maher. I really enjoyed the presentation of what has been done in terms of electricity provision for the roughly, correct me if I'm wrong, 17,000 shelters. And now what you are implementing in order to ensure equal distribution, longer hours of services, because now it's around 7 to 8 hours or 14 hours, if I'm correct. So thank you very much to also share the lessons learned on this type of solar mega power plants. Thank you so much. So we will now move to the chat and the questions. So feel free, of course, to yes, Maher, if you can stop sharing your screen, and I will share mine so that we can go on my road.
Sure.
So
yeah.
Thank you, merci.
Thanks.
Now you can move on to the Miro board if you want, with the link that Sadiq has or will share on the chat, so that you have, for your questions, you have a summary, pictures, and the model of delivery model that is used in Jordan. And I will also don't hesitate to jump verbally to ask a question directly to Maher. That would be very welcome. And I will start with the questions. Okay, let me go back to the first. So there is a question from Noor, who asks, will the energy be distributed throughout the day if the users regulate their energy consumption? So I think the question is without. Maybe Noor, if you can precise your question, without the dispensers or with the dispensers, that they can voluntarily regulate their energy consumption? That's a very good question.
Exactly.
Very good
Hi,
question.
Maher. Thank you for. Can you hear me, guys?
Yes, yes.
Yeah, we do, Noor. Go ahead, please.
Thank you for the presentation. I just wanted to ask, with the dispenser, will the energy, like if the users regulate their energy consumption, will they have like access to electricity for 24 hours throughout the day?
Answering, thank you so much, Noor, for this good question. Definitely, they will have a credit. They can use it the way they want, so they can get a 24/7 of electricity, provided that there is a cap or maximum energy allocated. So they can, the 2.6 credit, let's say, they can use it in 1 hour, or they can use it in 24 hours. So it's a way how to manage this credit or balance that's provided to them, and it was estimated to be covering the basic needs of these shelters.
Mm-hmm.
Yeah, I hope, Noor, this answer was clear to answer your question.
Yeah, thank you.
Sure, you're most welcome. Thanks, Noor.
Thank you, Maher. We have another question, which also it's look into the future, and it's very interesting, from Natalie, and say if there is any, due to increased electricity access, there should be, will be an accumulation of e-wastes. If there's any safeguard in place or planning to reduce e-waste or collect it or recycle it, yeah, some e-waste management plan, basically.
Perfect. This is a very important question related to the sustainability topic and environmental topic in particular. Thank you, Natalie, for raising up this point. Just to make it more clear, the energy dispensers will give increased energy access in hours. However, it will reduce the overall energy consumption of the camps. So as a result of the energy dispensers will reduce the carbon footprint and the e-waste of what we call the consumption or the appliances or the systems located in the households. This is in the first line. On the second line, we're also proud to say that in camps there are innovation centers, that refugees with a creative and innovative idea can be part of this lab or innovation center to provide ideas of recycling, energy efficiency, solar or off-grid systems. We always focus, and during the past weeks we were putting plans how to reduce the e-waste in our offices as well as the camps, because with increased sometimes access of electricity, as you mentioned, definitely people might buy more mobile phones, more tablets, computers, and definitely this might result in e-waste. However, this is mitigated again as carbon emissions. However, from e-waste point of view, we're looking forward to recycle or upcycle the e-waste coming from the refugee camps at household level. So I hope, Natalie, this answered your question and your point raising up for the e-waste. And thank you so much.
Thank you for a very detailed and clear answer, Maher.
Sure, thanks.
We have another question from Thomas, and is asking some detail regarding the legal framework when it comes to the who's the energy company which is responsible for the distribution. I think either of the electricity, but also of the dispensers. So yeah, a little bit about the legal and operational aspect of the distribution.
Perfect. Thank you, Thomas, for this question. Regarding the legal framework, if we're talking about the electric distribution, in Jordan we have one national company for generation, and we have one monopolized company for each area. So we have one company as a distribution for the north, one for the middle of Jordan, and one for the south. So we have only one company or one option for each city or for each camp. So the answer to this question, a company called Irbid Electricity Company is for AZRA Camp, ETCO company is for AZRA Camp. This goes to the distribution companies that we're working with for the electrical supply. Now for the companies supplying the energy dispensers, there are several international companies supplying these energy dispensers, and it depends on the specs you're looking for. They can customize it, or you can find it commercially in the market. Thank you.
Thank you, Maher. So if I understand correctly, the power plant is connected to the grid and
To the grid.
Yeah, and it feeds the grid and reduce as some kinds net metering the
Correct.
POC consumption. Okay.
Yeah. So again, the system installed in AZRA Camp, it's a net metering system. We are, as a camp, connected to the grid. We consume from the grid anything that we need extra. Sometimes we have extra generation. We export to the grid. It's registered as a credit, and we use it at night or evening times. So yes, at AZRA, it's fully 100% net metering. However, about 30% in AZRA Camp, it's a wheeling project, because we mentioned we have 3 phases in AZRA. Wheeling project, for those who never heard about the wheeling project, consider there is no enough land or area inside the camp or near the camp to install solar panels. So we rent or we buy a remote plot of land, we install solar panels, and we wheel or take the energy to that location or that camp. So this is something maybe implemented in Jordan. I'm not sure if it is well spread in other countries, but this is one of the incentives given by the government for those who want to install solar systems but don't have enough areas around the camp or around the offices they have. Thanks, Jonathan.
Thank you, Maher.
Sure.
Very clear. And this is indeed regarding the net metering. This is indeed the whole or part of the purpose of the dispensers. Beyond longer electricity time and equal distribution of electricity, it's also to regulate the extra consumption that you take or you might take or from the grid. That's in order to better regulate what's coming in and out and in between the camps. So yeah, as a reminder for the dispenser solution. Samira is asking a question, clarification question. She's asking whether both solar solar power plant system were in the camp were fully funded by grants, or maybe if you had more detail available about the financing aspects, I would say.
Perfect. Thank you so much, Samira, for this question. Regarding the donations, yes, the donations covered almost all the capex needed for building these farms. However, UNHCR is responsible for the operation and maintenance and the spare parts for these solar farms. So as a capex, it was fully funded by the donors. For the OPEX, UNHCR is responsible for this part.
Thank you. Very clear.
Sure.
Thank you.
Thanks. Sure.
Mahjoub is asking, can you explain the main role of stakeholders in this project, especially private sector? I think you covered this already, but maybe if you can, here I have it on but maybe if you can elaborate a little bit or
Sure.
just a quick summary of who did what in this project and in the dispenser project.
Perfect. Talking or speaking first about the solar project, again, distribution companies are private companies, ETCO and IDECO. These are two of the main stakeholders who gives us the approvals to install a net metering solar farm. So this was one of the basic roles for the private sector regarding the solar connection or net metering in both camps. Second thing, definitely, after getting the donation, we need a local company who has the expertise and the professional experience and the team to install these systems. So even the private sector was doing all the designs needed, the installation, safety plans to implement such a solution to be delivered for the UNHCR in the best form. So again, IDECO, ETCO, which are the utility companies, are private sector. The contractor was a private sector, and now also the operation and maintenance is part of the private sector. So the majority of the loop comes from the private sector. However, regulations, legal thing, and the framework comes from the government of how to connect these camps and what are the documents needed and the law, how to do it, and what is the tariff, and what is the remaining topics regarding the solar farm. Now, if we go to the energy dispensers project, it is still at an early stage. And this project, we were exploring technical specs, technical issues. We installed several units in AZRA Camp for testing and feedback. The feedback was really good with positive results. Now we are in the stage of looking for donors and funding organizations for CapEx to install these energy dispensers. The role of the private sector is to customize energy dispensers based on the needs that we want to be installed at the camps. What are the needs? Is to have a built-in option for prepaid feature that will be used in the future, to have an access remotely for all shelters to make sure all shelters have an equal amount of energy, with alarms if anybody tried to disconnect energy dispensers. So several things regarding the specs, safety for the refugees, and security of such energy dispensers. So several topics were like specs were determined by our technical unit team members, and we're exploring which are the suppliers who can customize and manufacture these scale up amount, because definitely the specs of 15 units after the trials and after the feedback we had came up with much more specs that are needed with the 17,000 energy dispensers needed. So private sector plays a really important role in implementing and in designing and customizing these energy projects. So I hope this question was answered in details for both solar and energy dispensers. Over and back to you, Jonathan. Thanks.
Yeah, thank you very much, Maher, for the
Sure.
detailed and precise answers. Please, people, we have the audience participant. We have 5 minutes left. So if you, before the break and then the wrap up and discussion about solution identification or simulation. So please write your question. We have one question for the moment from Thomas Giblin, which asks, have you considered the potential role of containerized battery with such a system using stacked used and new car batteries? Or this is not relevant for different reason with this model and in this situation?
Perfect. This is a valid suggestion, but not for Jordan. The reliability of the electric grid, we have electricity in the camps connected 24/7. However, we are controlling the hours sometimes just to reduce the energy consumption in these camps. Batteries are almost used in camps who doesn't have a grid reliability or very limited hours from the grid. However, the net metering solar project means free batteries in the grid. Again, you use batteries sometimes during extra generation when you don't have a grid, and then when you want extra electricity, you take it from the batteries. So in our model, net metering, we are exporting extra generation to the grid the electric meter for the electric company put credit or balance for us, and we can use it again. This reduces the e-waste to replace the whole batteries, and this makes less capex even for such a model. So answering this point, definitely it's a great suggestion, but not for the model of Jordan. So thank you so much, Thomas.
Thank you, Maher. Yeah, you showed that
Sure.
you use the grid as and the net
Battery storage.
Mechanism as a storage, electricity storage.
Correct. Yes, that's right.
Thank you. Very
Sure.
very interesting. I had, as I don't see any new question coming in, I had a question related to the time that was necessary to implement the power plant, but also what you expect the time necessary to implement the dispensers, because you have you have 17 or something.
17,000 shelters. Correct.
Yes, 17,000. Merci, Maher. And so that would require a quite extensive distribution of dispensers. So yeah, basically, what was the time frame for the power plant, and what is the expected time frame to implement the dispenser? Thank you.
Perfect. Definitely for any project, and even when you approach donors, a timeline is highly needed and recommended to know if the project will be implemented in a few months or several years, or sometimes with a dead end when you don't get approvals or legal framework that's clear in that country. So basically the advice is also to double check always the legal issues of such a solution. And for the timeline, we sometimes explore timelines with different installation or contractors and suppliers. However, for the energy dispensers, the timeline ranges between 1 up to maximum of 3 years. However, our ambition is, as soon as we get the fund, we need to finalize the whole dispensers project within 12 months. So
Okay.
this is for the energy dispensers. Now going to the solar plants, it varies based on the type of the project. Net metering project, it can take up to about 12 months of getting approvals, installation and commissioning. But for wheeling projects, it might need extra studies because you are building in a remote area. They need to study the loads around it and how this energy can be consumed in the land plot that has a solar panels remotely. So wheeling projects sometimes take up to 18 months, or took about 18 months, but for the net metering around 12 months plus and minus based on the camp area. And for the dispensers, as we said, it's 1 up to 3 years. Thank you.
Okay, very clear. Thank you very much.
Sure, thanks.
If anyone wants to ask a question, also verbally. Otherwise, I think we can wrap up here. I really enjoyed the details and your contribution in sharing a knowledge and lessons learned and good practice. It's an amazing project and job you have done in providing such level of electricity, which is around tier 3 to some extent. And also we did not talk about it here, but there is also you providing electricity for productive use of electricity for what is called the market. So it's not only households, but it's a whole, and it shows that how the complexity of providing such a level of services to a household in displacement setting. So thank you very much for clarifying this or illustrating all this this afternoon, and thank you. And we will keep you, we will also post the presentation on the website. So if someone is interested in discussing, also if you want to go back to us for questions. Thank you very much, Maher. Thank you.
You're most welcome. I'm thrilled to be with you, Jonathan, and with this audience, and really impressive questions and discussion. I was happy to hear such technical questions and legal questions, how things are going on here in Jordan. I'm always looking forward to assist anybody who has a question regarding our experience, because we always focus on knowledge share. Sharing our experiences, lesson learned, will definitely help other POCs in other countries. So thank you again, Jonathan, for this invitation, and looking forward for further collaboration.
Definitely. Thank
Sure.
you. Thank you, Maher.
Sure. Thank you as well.
So now we will have a break until for a little bit more than 5 minutes until a 10 to 3 or just a 10 minutes before the 2 or wherever you are, depending on your time zone.